All right, let's check out another Mtel question here. This one says, use the diagram below to answer the question that follows. So the diagram shows a figure made up of a quarter circle adjacent to a rectangle that has the dimensions z by 2z. If the figure is rotated around line L, which of the following expressions represents the volume of the rotated figure? All right, so this question involves some visualization. Hopefully you can see that if you were to rotate this shape around the line they're telling us about, this would look a lot like a silo, right? Like it would have that cylinder shape with a dome on top. So we could extend this shape to look like this if we rotate it around. And hopefully you can see that in 3 dimensions, that it would be like a rocket ship almost. So the top of the shape is going to be half of a sphere, it would appear, because we have half of a circle rotated around, and this bottom portion is going to be a cylinder. So we have 2 separate shapes making up this larger shape, and we're going to be talking about the volume of both of those shapes. So since we're talking about volume of a sphere and volume of a cylinder, let's write those equations down. So volume of a sphere is 4/3 times pi times r cubed. And volume of a cylinder is the area of the base of the cylinder, which is a circle, so that's pi times r squared times the height. So in this picture we have half of a sphere and the full cylinder. So we can actually take this equation, divide it by 2, and just add it to this equation, and that should give us our full equation. We do have some measurements that we can plug in here using these z's. So to find the volume of this top part of the half sphere, it would be, I'm going to say volume of sphere equals, I'm going to end up dividing this by 2 because it's only a half of a sphere. So it's 4/3 times pi times r cubed, which in this case is just z cubed, because z is the radius of this circle. Hopefully that's easy enough to see. You can translate this up here, and that's the radius of the quarter circle that they gave us. So z cubed would be this, and then we're just dividing that by 2, and then plugging our z's into our cylinder equation. We'd have the cylinder would equal, so pi r squared, so pi times our r, which is z squared, and then times the height, which is 2z. And we're going to add these 2 equations together eventually. I'm going to simplify them as much as I can. I think this top equation is basically simplified. I think we can divide this 2 into the 4/3 and make this 2/3. So that's one simplification step we can do. So volume of the sphere is 2/3 times pi times z cubed, and then volume of the cylinder, we can just combine z squared times 2z would just be pi times 2z cubed. So when we add these 2 things together, we have 2/3 pi z cubed plus 2 times pi times z cubed. So since these are exactly the same, and we have numbers multiplying by them, we can just add 2/3 and 2, and that should give us a simplified expression. So 2, if I turn 2 into a number represented by thirds, 2 is just 6/3. 6/3 is the same as 2, and that should allow us to add these 2 fractions. So our combined expression should be 8/3 times pi times z cubed, which is just another way of writing answer B.